Hey physics students, so in our last lesson we talked about position and time and velocity, and we made some position versus time graphs, and we are still working on being able to describe the relationship between displacement, velocity, acceleration, and time. What we're going to do today is a little lab activity. I have a vehicle here, a little vehicle that's supposed to move at a constant velocity. Right? What we're going to do is we're going to set up a little track, and we're going to let it run along the little track, and we're going to take some data about its position and time, and we're going to use that to make a graph of position versus time. And then we'll find the slope of that graph and see if we can find what the velocity of this little vehicle is. So let's go ahead and let's set that up and let's take a look. Okay, I've set up on the floor here. I've got 3 meter sticks end to end, and I put a little bit of tape so that they don't move. And what I'm going to do is I'm going to take my car and I'm going to start at the end of that first meter stick, and I'm going to let it go, and I'm going to let it run until it gets to the middle of that first meter stick at 50 centimeters. At that point it will have gone half a meter, 0.50 meters. Okay? And I'm going to time how long that's going to happen. And then what I'm going to do is I'm going to start it back at the beginning, and I'm going to let it run to the end of that first meter stick. Okay, so it will have gone 1.00 meters. And then I'm going to time how long it takes for that to happen. And I'm going to continue doing that, and I'm going to do that for each half meter. So I'm going to time how long it takes to get to half a meter, 1 meter, 1.5 meters, 2 meters, and so forth, until I fill up my data table. So I'm going to try to position the camera so that you can see the place where it's going to end, and then we'll time how long it takes to get there. So let's take a look. Okay, here is where my car is going to start, and if you can see the toothpick I have down here, that's pointing right at the 50 centimeter mark. And I'm going to start my car and let it go that far, and we'll time how long it takes. Adjust the camera angle for the different distances. Now here I have my toothpick at 1.00 meters. So I'm going to run my car and I'll time how long it takes. From here I think I'm going to have to move the camera. So here I have my starting point, and if you can see way down there at 1.5 meters, I have my toothpick, that's my ending point. So let me start my car and time this one. Now I have way down here at 2 meters, my ending point, my toothpick there. So let's start our car and time this one. Okay, last one I have room for on my data table. I have my toothpick all the way down here at 2.50 meters. So let's start the car. Time how long this one takes. Alright, so now I have recorded all of the positions and times in my data table on my lab handout, and now I'm going to enter this data into graphical analysis, and we will make a graph and find its slope, and that slope should tell us what is the velocity of my vehicle. So I'm going to choose manual entry so I can enter my data by hand. On my y-axis, I am going to put the position, which we measured in meters. On the x-axis, I am going to put the time, which we measured in seconds. I'm going to title my graph Position versus Time. Very good title for a position versus time graph. And let's enter our data. So my first data point, my car was at 0 meters, and it was there at 0 seconds. My second one, the first data point I actually took, it was at half a meter, 0.50 meters. It was there at 1.38 seconds. And then when the car was at 1.00 meters, it was there at 2.81 seconds. Let's see, at 1.50 meters. 1.50 meters. The car was there at 3.81 seconds. 3.81. At 2.00 meters, the car was there at 5.50 seconds. And then at 2.50 meters, my last data point, it was there at 6.69 seconds. Okay, so it looks like my points line up pretty well here. This one looks like it might be a little bit higher than the other one, than the line, but that's still pretty darn close. It's pretty good. Let's find the slope of the line. I'm going to go to Curve Fit, and I believe it should be a linear. Since it's a constant speed vehicle, then my slope should be a straight line. So let's choose that one. And here we go. According to this, my slope is 0.3729. And I believe I should trust that to about 2 significant figures. My least significant measurement was 0.50 meters, which is 2 significant figures. So I'm going to trust that to 2 significant figures. So we'll say it's 0.37 meters per second. So how fast does my car go? 0.37 meters per second. Okay, the second half of the lab wants us to do this again, but backwards. So now we're going to start at the other end of our little track here, right? So, like I said at the beginning, I have 3 meter sticks, so my little track is 3 meters long. So I'm going to start my car at the position 3 meters and let it run the other way, okay? So, and what I'll do is I will let it run to 2.5 meters and time how long that takes, and then I'll let it run to 2 meters, time how long that takes, and so forth until I fill up my data table. So let's go ahead and do some of those. Okay, so here is 3 meters, and here's my toothpick at 2.5 meters. Let's run our car. Okay, here's 3 meters, and here's 2 meters. Here is 3 meters, and here is 1.5. At this point, I'm going to have to move the camera. So over here, this is 3 meters, and then way over here is 1 meter. So let's run our car. Finally, last one we're going to take 3 meters, and it's going to go all the way down to 0.5 meters. So let's run this and time this one. All right, let's make our graph for this one. Hopefully, since the vehicle has a constant speed, we should get the same speed as we got last time. If you recall last time, we got 0.37 meters per second for the speed of the vehicle. So maybe we won't get exactly the same. I mean, there's some little, error in measurement, but hopefully we get something pretty close. So let me pick manual entry here. Set up my table here on the y-axis. We'll put the position, meters. On the x-axis, we'll put time, seconds, and show my graph, position versus time. Let me put some points on here. When my car started, it was at 3 meters, 3.00 meters, and it was there at 0 seconds. At position 2.50 meters, it took 1.50 seconds to get there. At position 2.00 meters, it took 2.75 seconds to get there. Position 1.50 meters took 4.06 seconds to get there. 4.06 seconds. Let's see, position 1.00 meters. How long did it take to get there? 5.55 seconds. And then at 0.5 meters, it took 6.75 seconds. All right, you can see our graph looks a little bit different from last time, and we should expect this because our car was moving backwards. So rather than having a slope that goes up, I would expect a slope that goes down, and that's what we can see here. And these points look like they line up really very well. So let's do a curve fit and see what the slope is. So let's see, curve fit should be linear. And there we go. And again, let's trust this to two significant figures, and you can see the slope there. It says negative 0.3704. And what does that tell us? That tells us the velocity is 0.37 meters per second, and the negative tells us that it is backwards. So we got 0.37 meters per second for the slope, for the velocity, both times. So it claims, the vehicle claims that it's a constant speed vehicle, and we can see that it is. We get the same velocity both times that we measure it here. Once forward and once backward. So pretty neat there. Alright, so there was our position versus time lab. We found the speed of our vehicle going forward, and we found the speed of our vehicle going backwards. And we found the same velocity each way. So when it was going backwards, it was negative, and when it was going forward, it was positive. So pretty neat there. Hopefully that helps us to be able to describe the relationships between displacement, time, velocity, and acceleration. Next time, we'll go ahead and we'll talk about acceleration. We'll do velocity versus time graphs, and we'll learn about the slope of that line. So until then, take it easy.